Alrighty, let me check. Do I got sound? Check. 1, 2, check. Okay, good. Sound seems to be working. Alright, once again. Okay, so now this is what we actually ended on whatever day last class was. Uh, complex fractions. Alright. So basically, a complex fraction has a fraction within a fraction. For example, the examples the book uses, I guess I'll go with those. We got 4y, 4 over y. These. And this gets a little tricky reading by hand, but I'll just try to make it darker so that you know it's the main division line. This big longer one. So basically, here you have a sum involving a fraction. Here you just have a fraction in the top and a fraction here subtracted. And here you got a fraction in the top, a fraction in the bottom. So basically, you just got and you notice the entire thing is a fraction. So you basically have a big fraction, and then you got fractions in the numerator and so on. But basically, these are complex fractions. And there's a lot of other ones I can do, or plenty of them I can do, but hopefully you got the gist of that. Alright, so before I even do an example, since not as time restricted, I can go into a little more detail. We got, let's just say we have 30, well, let's just say we have 3 over 2 over, actually, no. Let's just say we have 3 over 2 divided by 5 over 7. Okay. How do we do that? When we first learned how to divide fractions, we learned how to multiply first because you had to do one to do. If you could do one, you could do the other. So basically, you just flip the second one and multiply straight across, basically. So you flip and then replace your division with multiplication. So you got 3 halves times 7 over 5. So basically, you just multiply by the reciprocal. It's going to be 3 times 7 over 2 times 5, which is 21 over 10. Okay, so that's all you do. As I said before in class, the rules don't change just because you have variables. These letters basically are just placeholders for actual numbers. So the rules are not going to change just because it's a letter instead of a number. Because these letters are numbers. They represent something. You don't know what they represent, but they definitely represent something. Okay, why did my something just disappeared? That's nice. My annotations just disappeared. Well, fortunately, this is all recorded, so even if I lost it, you should still have it in video world. That's kind of annoying. Not sure why that happened. I have no idea what's going on right now. Okay, I'm just going to move to another slide because this thing's kind of acting weird on me. Okay, so pointer options. Alright, thing's kind of acting a little funky on me. Unless maybe I'm accidentally hitting the trackpad, but turn the trackpad off. Maybe that'll help. Nice, didn't tell me. Alright. Let's see if I can get past our minor technical difficulties. Not a good start. Alright, so x plus 1 over x all over x minus 1 over 2x. Alright, so this big division symbol is saying divide this fraction by this fraction. So basically, I'm saying x plus 1 over x divided by x minus 1 over 2x, which is just going to be equal to x plus 1 over x. Flip the second one and multiply 2x over x minus 1, which basically is going to be, you notice they both have an x in the numerator and denominator. So really, these, something divided by itself is 1. So I'm basically left with 2 times x plus 1 over x minus 1. And that is my final result. Alright, so let's check out part B. Two plus 1 over y divided by 3 minus 2 over y. Alright, so the book does this a little different. I'm going to show you one way to do it and one way only, because it relates back to how you learn how to do fractions in like elementary school. So it's pretty straightforward if you do it that way. They do give you some shortcuts and little memorization tools in the book, but again, as I've stated repeatedly, I'm not a big fan of memorizing things. So do it how you want to do it, but I'm just going to discuss it using basic rules of using basic rules of arithmetic. So basically we have 2 plus 1 over y divided by 3 minus 2 over y. Alright, that's what that means. These are equivalent statements. So basically, I don't have a fraction divided by a fraction yet. I got a sum divided by another sum. So I need to write these as a single fraction and write this as a single fraction. So basically what I have is 2y over y plus 1. And if you not familiar, not sure why I wrote it like this, you should review the last lecture video. Times, no, not there yet. Divided by 3y over y minus 2. So basically that is going to be 2y plus 1 over y all times y over 3y minus 2. Y divided by y is 1, so I'm left with 2y plus 1 over 3y minus 2. Right. And that's all there is to that. It's pretty straightforward. Example 2, which I don't know, it's about 4 o'clock in the morning, I think. So I think everything's starting to look the same. But let's see. Let me look back here. What is that? Okay, that was example 1. This is example. What is going on here? Oh, something weird is going on. Okay, I keep losing my freaking information. Keep losing it. Keep losing my darn. Oh well. Fortunately, this is being recorded, so you still have it. I don't know why my annotations keep getting lost. This is not going very smoothly, but I'll proceed. Alright. Glad this is being recorded. Alright, so we'll try this one, part B. We got 2p plus 5 over p minus 1. So, And this again is 2b. So example 2b. Alright, in your text, and that is all divided by 3p minus 2 over p. Alright, so what I have is, so again I'm going to do the same thing. So it's going to be, and I'm going to go ahead and do this in one step. So you have, well actually no, I won't. 2p plus 5 over p minus 1 divided by 3p minus 2 over p. Right. So that is going to be equal to 2p times p minus 1 over p minus 1. Common denominator of these two is going to be p minus 1, and this is already p minus 1. Kind of throwing in some middle steps because this one's a little longer, and I actually made an error on when I was starting to cover last class. Alright, so 3p, our common denominator is going to be p, so we're going to do 3p times p over p, so that we see that p divided by p is 1, so we just get 3p, so that's fine. And this is already has a p as a denominator, so basically what I'm going to end up with is, start out with, because I'm still got a little ways to go. Alright, so I have 2p squared minus 2p plus 5 over p minus 1 divided by 3p squared minus 2 over p. Alright, let's double check to make sure all our values are right. Alright, so that is p squared minus 2p, that's a 5, that's 3p squared, that's minus 2, it's all over p. Looks so far so good. So let's move on. I gotta copy this over. Alright, so 2p squared minus 2p plus 5 p minus 1 times p over 3p squared minus 2. Alright. Alright, so nothing's really going to factor here. So basically what I'm going to end up with is multiplying tops, 2p cubed minus 2p squared plus, because remember I'm multiplying this whole thing times p. This is distributed all to here, here, and here. Remember, distribute. Be very careful. And plus 5p. That is going to be divided by this product. This times this, basically. So I'm going to have 3p cubed let me see, minus 2p minus 3p squared plus 2. Okay, and the order of the exponents is just addition, so the order of this doesn't matter, but only thing is in the text they swapped this term and this term around, but it's the same result. Alright, so that's what you end up with. 2p squared minus 2p5 minus 2p squared minus 2p. Okay, good. Alright, that works out. It's getting late. Alright, example 3. I gotta buy us some time because we don't have a lot of time left in the semester, so kind of killing myself to stay awake to do this. Alright, so we have a so 2 over x minus 3 divided by 5 over x squared minus 9, and that gives me something. And actually, if it helps, go ahead and put parentheses around it. At least you can keep up with what's the numerator and what's the denominator a little better if you do that, I think. So, and I kind of filled up the screen, which I wasn't trying to do, but basically, we have 2x, 2 over x minus 3, and the bottom one, that's going to be times. I'm going to cut to the chase here. You flip the second thing here to what you're dividing by, so it's going to be x squared minus 9 over 5. I hope you guys follow that. If not, please ask questions in class, but I'm just kind of cutting to the chase here. So we basically have that is going to be 2, and then this is going to be x plus 3 times x minus 3 divided by x minus 3 times 5. This cancels and just gives you 2x plus 3 over 5. Is that 2x plus 3 over 5. And that's your final result there. The book tells you 2 different methods of doing it, neither of which I think is a method that I'm doing. So I guess if you look at the book, you'll have 3 ways of doing it. So if you're like stuck in your brain, go right ahead. Alright, so same thing we've been doing. I can rewrite this as 1 over x plus 1 over y divided by 1 over x squared minus 1 over y. So single fraction, I'm going to have 1, so I have x plus, no, I'm not going to have that. Erase. Technically correct, but not as easy to understand if I write it that way. And why does this stuff not go away? Erase. Oh well. Seems to want to be stubborn. Screen options. What this does. It's kind of neat. Screen options. That'll work. Okay, so now if I can stop writing crooked late and early this morning. Okay, I'm still writing crooked. Whatever. Alright, so I have something divided by something else. I think I'm getting too tired for this. Alright, so let's see here. So we got xy is going to be my common denominator. So it's going to be 1 times x plus 1 times, I keep doing that, 2y, this will be x. And this is going to be y, 1 times y minus 1 times x squared. Okay. And again, you should look in your last section on how to combine the fractions. So now, if I simplify, I have x plus y over xy times x squared y over y minus x squared. All right. So some things are going to cancel. This y divided by y is 1. Actually, let me make sure I copy this problem right. No, I did not copy the problem right. That should be y squared. So this is y squared, which means this is y squared, and this is y squared. I copied the problem wrong. So this eraser. Okay, so this is squared, and this is squared. Okay, so basically, this is going to be x plus y, and actually, this is x divided by x squared. That's just going to leave me with x. Y squared divided by y. It's just going to leave me with y. Hopefully you can follow that cancellation. If you can't, like I said, please ask me, email me, something in class, or just email me. So x plus y over 1, which I guess I could have just wrote x plus y, but anyway, that's xy over, and I guess I didn't need this big parenthesis. Let me erase that. Yeah, erasing is a little bit annoying. So this denominator is going to be y plus x and y minus x. So basically, this and this are going to go away. So I'm left with xy over y minus x. Alright, so many more examples. Looks like two more examples in this section. Looks like, actually, one. Okay, and this is the last example of this section. Pretty short section, actually. Example 4. So here we want to simplify. Okay, so we got a rational expressions. Here we have negative exponents in this example. So we have m to the minus 1 plus p to the minus 2 over 2m to the minus 2 minus p to the minus 1. Alright, so basically, Remember, if you have x to the minus n, that's just going to be equal to, not implied, that's just equal to 1 over x to the n. Just like if I have 1 over x to the minus n, just as x to the n. Basically, you just move it to the other side. To the numerator, you move it to the denominator. Denominator, you move it to the numerator and make it positive. But do not do this. Don't do this. That is absolutely wrong. Okay, you can't do that. You cannot do that. You don't move this. You can't separate them and move them across. This is absolutely wrong. Do not do this. Don't. Okay, that is absolutely wrong. Okay, this is how you go about that. So let's rewrite this. To m to the minus 2 minus p to the minus 1. So basically, when you rewrite this, write it as a fraction, basically. So it's going to be 1 over m plus p squared, 1 over p squared. And then this is going to be, and remember, it's not the power is tacked on to this. It's not tacked on to the 2, just the m. Okay, if it was a parenthesis, this is not the same as this. Okay, this is this. This is 1 over okay, these are not the same. Okay, another thing to be careful about, and I keep taking all these sidebars, but there's a lot of things, a lot of room for error in these problems. So anyway, so basically leave the 2 alone. It's going to be in the numerator. So it's going to be 2, and I kind of cut myself out of room there. So let's see here. So we have 2 over m squared minus 1 over p. So that's all we have. So now we're back where we were before. So we got 1 over m plus 1 over p squared divided by 2 over m squared minus 1 over p. Okay, so that is equal to p squared over m p squared plus m over p squared m. And I'm running out of room. So 2p over m squared p minus m squared over p m squared. Yeah, so notice if I'm moving back and forth between here and here and here and here, nothing changes. Okay, this cancels and gives you what you started with, and like always. So writing them as a single fraction, I have p squared plus m over m p squared divided by 2p minus m squared over m m squared p. Alright, so when I rewrite this, it's just going to be, if I can squeeze this over here, p squared plus m over m p squared times m squared p over 2p minus m squared. All right. Alrighty, so that cancels. The square, that cancels. So I'm left with p squared plus m times m over p times 2p minus m squared, which doesn't simplify. I mean, this is perfectly acceptable, or if you want to expand it, you can have what the book has, which is p squared m plus m squared, and then that's going to be 2p squared minus m squared p. Yeah. Basically, both of these are acceptable. There's no difference. It just depends on how you want to apply it. I mean, it's not really going to be any difference in what you actually get. So basically, and actually, I one more example. I guess that was part A. Yeah, so that was A. That was part A, and for part B, they had, and this is the last one of the section. Hurrah! Minus 2y to the negative 1. That's an exponent. That's hard to tell. I'm writing a little sloppy at 4 o'clock in the morning. Y minus 2x squared. Okay, so in this case, only the numerator is written in terms of a negative exponent. So basically, I can rewrite that as x 1 over x squared minus 2 over y all over y minus 2x squared. And that's what we've been doing. We have 1 over x squared minus 2y. So that is y over x squared y minus 2x squared. Let's see here. Okay. And that's going to be times You need time to think for a moment. How do I rewrite this second part, the thing that's being divided by, the thing you're dividing by? How do I rewrite that as I'm supposed to flip it, so to speak? So when I say I flip it, the mathematical term is you're taking the reciprocal. Well, the reciprocal of a whole number, if I had 3, would be 1 over 3. The same thing here. If I have y minus 2x squared, well, that's all understood to be over 1. So basically, I have 1 over y minus 2x squared. So basically, this cancels, and I end up with just 1 over x squared y. And that's the end. All right. I hope this was informative, and I'm going to try to go ahead and record the next lecture if I can stay awake for it. It is, I guess you can probably see the time on my desk on this recorder. Let's see here. Let's stop this thing. We'll stop this thing. Oh, yeah, right. Stop. That's how I stop it with the stop button.